This is the Under the Pier show, my arcade on Southwold Pier. Open up any of the machines and you'll see rows of connectors inside. They're essential for maintenance, testing and replacing parts, but they're fiddly, unglamorous and rather frustrating to use generally. So I'm not a connector expert, but this video is about my experience of using lots and lots of different types of them. If you want to skip to a particular chapter, here are the contents. So I thought I'd start with a simple one, and it's one I actually do like. It's the jack plug. So this goes back a long way. It was used before 1900 in telephone exchanges for the operators to put people through, long before their automatic exchanges. So it's very simple, and this is the socket, I should say. I've just connected it to a light there. You push it in and it makes the connection. And what's happening with these two little springy bits of phosphor bronze in there, coated with a very, very thin layer of gold, you can see what happens as I push the pin in. It pushes the springy bits apart, so they're pushing down on the plug, and that's what makes the electrical connection. And all connectors are the same really, they all rely on springy bits of metal of one sort or another. Well, obviously connectors vary in size according to how much electricity they're connecting. The biggest one I could find is switching 1.5 megawatts. This is a connector connecting a cruise ship to the dock, so the ship can turn off its diesel engines. At the other end of the spectrum are the tiny, tiny collectors you get inside phones and laptops and cameras and things. The jack plug is somewhere in between the cruise ship and the camera. So this is rated about 5 amps. So I'll now try and show you what happens if you connect it to a lot more. Basically it gets hot. So here's my socket and the plug. So I'm connecting this to my welder, which is about 130 amps. Not looking good. Nothing left of it. Nothing left of it at all. So it's important to know what current's going through your connector. Well, sometimes you don't know what current is going through it and you have to measure it. That's where you need a meter. Well, I know people get confused trying to measure current with a meter, so I thought I'd give you a quick demonstration. Normally you use a meter just for measuring voltage and stuff, and so then that's what most people are used to. You just turn it onto the volts, and then so if I connect my light, just make it slightly less glary, the voltage across the light is 9.2 volts. And measuring the current, you have to change several things. Obviously you have to move the meter around to the right setting. You then have to move the positive terminal across. You see this row says volts and A for amps is at the other side, so you put it in there. But then to measure it, you don't put it across the terminal of the light like I did for the last one. We have to unsolder or undo one connection in the circuit, and then we add the meter into the circuits in series. So if I connect this up now and connect one wire here, one wire there, that's the current going through the LED. It's a power LED, so it's actually taking 0.85 of an amp. So my 5 amp connector is quite fine for the current actually going through this little LED. Although obviously different size connectors are needed for different amounts of current, it's not enough really to explain the millions and millions of different types that exist. When I got out my collection of connectors, I couldn't believe how many I'd used in the past. And of course, if you think of computers, their plugs and sockets change every year or two. A lot of it is because of once a connector has been invented, you can't really get rid of it. There'll be things that use that format for a long, long time. So I was going to illustrate this with a characterful plug, the UK mains plug. This was introduced in Britain in 1947 and heralded as the most advanced connector in the world. The enormous size is mainly because there's a fuse inside every plug. If you don't live in Britain, you've probably never seen inside one. There's the fuse running up that side. That's the live pin, the neutral pin and the earth pin. There's also quite a lot of space in there too. The other reason why they're so large is that the pins stick out so far. The earth pin sticks out a really long way. Well, this was all done for safety, but I then later read that it was partly because we had a great shortage of copper after the war, and they realised that they could save copper by, instead of having a wire from each socket running back to the fuse box, you could connect all the sockets round in a ring and then run one wire back to the fuse box. But in order to make that work, you had to have a fuse in every plug to protect the cable to the appliance. So that's why the fuse is inside. The long earth pin, this was a safety device. You can see the copper of the earth in the socket. So when you put the plug in, that's the first thing that makes contact. Then also, you see their shutters over the live and neutral pin. So the next thing that happens, once the earth has made contact, is that the shutters are pushed out of the way, but the live and neutral don't finally make contact until they've reached the shrouded part of the pins. Then you finally plug it in and make the connection. So it was extremely safe. But of course now there's no longer a copper shortage, and since then very, very sensitive trip switches have been introduced and have replaced the fuses in fuse boxes. So the chances of getting a shock now are extremely remote. So our characterful plug is really now rather outdated, but of course there's no chance of it going away in the near future. We're stuck with it. So one way of categorising all these millions of different types of connectors is how the wire's attached. So like in the 13 amp plug, they're screwed into the connector. In the jack plug they were soldered. Then other connectors are spring clamps, and others the wires are crimped into the connector. So I'm going to look at each of these in turn. Well, the most common sort of screw clamp are these funny little things, these connector strips, sometimes called chocolate strip because vague resemblance to a Toblerone bar or something. They're brass inside, with 2 screws on top. You undo the screw, you probably know these already, and then you push the wire in, and screw it up. What could be simpler than that, you might think? Well, actually they're frustrating things, particularly frustrating. Might even be my worst sort of connector. These are some of the things that can go wrong. If you try and put the second wire in, sometimes you can't get it far enough because the first wire's gone too far, and then you have to undo it and undo it up again. Then even if that's not the case and you can start to get it in, it gets harder if you want to put two wires in. Well, I might just have done it this time, but it's a sort of, it's touch and go whether that works. Okay, so then you start to tighten it up. But very often the screw just keeps on turning forever because they're so cheaply made. The thread often strips the brass, and so you carry on tightening, but the screw's not getting, the joint's not getting any tighter. So probably I should pull out again. Yeah, not my favourites, as you can see. They do have their uses though. I still got quite a few of them, and they come in different sorts. You can get a variety that's actually unpluggable, which can be useful on some occasions. You can also get much bigger ones too, because that's the ordinary size than these giant ones. But there is a better design of a screw clamp called the rising clamp. Oops, got to get the screwdriver. Slightly funny angle here. Yeah, I'm now doing it up. You can probably just see the clamp rising and squashing the wire in place. And that's a very firm connection. Well, these things are industrial connectors. This is just for connecting one wire to another. And usually I use them in whole rows connected to this rail. The rail is called DIN rail, and these are called DIN rail connectors. And you can see them in most of my machines. Well, you might think that solves the problem, they're perfect. But in fact, I struggle with these ones too. It's surprising how often wires can get trapped under the sides of the connectors, or somehow even go underneath if they're half done up when you put the wire in. It's not by any means foolproof, but it is an improvement. So a few tips about using screw connectors. The first one is that these things are very useful. These are called bootlace ferrules. So there's one for every different diameter of wire, and they're really just little metal tubes. So you push the wire into it, and then you have a pair of crimping pliers that go around it and squash the crimp round the wire. So then it won't fall off. It's very well held. And then that avoids all little stray wires getting trapped down the side of those connectors. And the other advantage is that you can use them in conjunction with cable numbers, so they can't fall off the ends of the wires. I use this in a lot of my machines, my older machines at least. It's still not perfect though, because I'm always cramped for space, so I end up trying to push several bootlace ferrules into one of those connectors, and it's always a bit of a struggle. Well, another tip, this is really just using screw connectors, and not really so much the rising clamp ones, but using them with single strand wire. Because a single strand of wire can go to one side of the screw and not clamp very well. So what you have to do is to double it up with a pair of pliers. So this is more important with domestic wiring, large-scale wiring behind a socket. These are also screw terminals. The cable is often single strand, so you have to strip it back quite a long way. And then double it up and push it into the socket. And then you get a nice strong connection. It's important to use the right size screwdriver. And actually that's the final tip, is about screwdrivers. when you buy a new screwdriver, this one's quite new, the ends are all nice and square. There's a nice rectangle, exactly the shape of the screw head. But as they get older, they all get rather rounded off. So the thing to do is just to grind them back to their original profile on a linisher. It's very quick and easy to do, and it certainly makes it easier to do screws up tightly, which is important with connectors. In many situations, screw clamp terminals have largely been replaced by spring clamp. This one is a little block that's a bit similar to the DIN rail connectors that I used, and they're very ingenious. I've only really started using them quite recently. I was slow to catch on. So each terminal has two holes, one for the wire there, and this one is to put the screwdriver in. You can see what's inside on the side view. This is the conductor that connects the two sides, one wire to the other, and this is a springy bit of metal. So when I push my screwdriver in, it pushes that springy bit of metal and opens up the hole for the wire. So if I can just show you more easily with the unstripped end. So if I now put the stripped end through, all I've got to do is to now remove the screwdriver. That is now very well clamped. There's no way I could get that out. You can sort of see how that springy bit is clamping against the wire. Well, these aren't perfect. Quite often if you're stuffing a wire in from some funny angle, it won't go through, and it's usually because a strand or two has got in the wrong place. It helps to twizzle the end of the wire or put a bootlace ferrule on. And it's also difficult if you want to put more than one wire in, which I often do. Though I think they are an improvement generally on screw terminals, and in my recent machines I have taken to using them. They come in all sorts of shapes and sizes. These little ones are very much like electricians use a lot now for household wiring. You don't need a screwdriver with these ones. You just have two little levers that you pull up, and then the two wires you want to connect go in here. So I'll stuff one in here and pull down that lever, and then that one's clamped, and then I'll put the other one in here, pull down that lever, and again they're very, very well clamped, very, very well clamped. And another thing I like about these ones is that there's, well, where is it? That's it. There's a little hole in the end, and that's for putting a probe from your multimeter in, so you can get at it to test the voltage. So yeah, they're good. Another spring clamp that I particularly like is this one. This is what I've taken to using as a replacement for the old screw terminals on my control panels. It's more compact, it's cheaper, and more appropriate, because these are rated at 25 amps, which I never use, and I think these are rated at 10 amps, which is plenty. You can connect just as many of them as you want, so if you want an extra terminal, it just clips in the end here. And to fix another wire in, you just push the screwdriver down on top and the wire goes in the side. And they're actually a good replacement for the ghastly chocolate strip too. These are good. The only trouble I have with these is that the spring clamps, they need to be quite strong springs to clamp the wire, so you do have to push hard, and sometimes it's difficult to get in the right position to push hard enough to open them up. There's one machine which kept almost falling over when I tried to push on the control panel. The jack plug that I started the video with, the wires are soldered to the plug. I use quite a few different soldered connectors. I think perhaps my favourite are these ones. These are D-pin connectors, they're called. The sort of shape is always slightly D-shaped. And they're nice to solder to, because on the back they have these things called solder buckets. You poke the wire, each wire, into a bucket, and it kind of holds it there while you solder. I'll solder a few up so you can see. It helps to clamp or stick the connector while so it doesn't move around while you're soldering. And also, if you can get the wire to just stay there without having to hold it, that makes life easier, because then you've got one hand for the soldering iron and one for the solder, and then the solder will flow into both. It's actually rather satisfying soldering up these little things, and they're very versatile. They come in lots of different numbers of pins, and then you can get what are called shells, so you can protect the wires and clamp them inside there, and you can get waterproof ones as well. So they're rated at 5 amps, but you can get even more high-powered terminals. This is an old smart motor, and you can see the 2 power pins for the motor load. These take about 10 amps, but I think I read that you can actually get ones that will take an incredible 40 amps, so pretty amazing range.
Delicious, what a lovely flavour.
This machine's a story about bed bugs. It has 15 scenes which spring to life in turn. My machines continue to get more complicated, so I've had to get more organised about my connectors. You can see this one's full of D connectors inside, one for each scene. Well, one thing to be aware of with solder terminals is that the wires are very close together. Bits of the solder sometimes just leave a sort of a funny bit sticking out, or there's a strand of wire, so it's quite easy for a wire, the 2 wires to join accidentally. I haven't actually ever had that problem with one of these, but I did have it with this little sensor I used on a donations box for Guy's Hospital in London. You roll the coins past the sensor and try to get them into the nurse's cup as she rotates. It's a slotted opto sensor, so when the coin interrupts the slot as it rolls down the chute, it breaks the beam. So I'd installed it in rather a hurry. It was a replacement for another sensor. And then later on, I had this mysterious intermittent fault. They would ring up and say it wasn't working, and I would go back and it would be working perfectly. And it went on for months. It took quite a long time for me to travel there. I eventually found it was from a stray strand of wire in one of the wires to this sensor. And when people shook the front of the machine, sometimes it made contact and sometimes it didn't. So ever since then, I've put heat shrink over the ends of wires like this, and tried to do the same with solder bucket terminals too. So if you haven't come across heat shrink before, you usually buy it in these great big reels, although you can get smaller amounts. So all you have to do is to cut the lengths you want, slip them over the wires, and then heat the whole thing up with a heat gun. It's really rather magic the way it shrinks. Well, it's very useful stuff. It comes in all sorts of shapes and sizes. You can get really big pieces, and the amount it shrinks is really quite extraordinary. I think it's just about finished shrinking now. Such an enormous difference. Well, while we're on the subject of heat shrink, another useful trick for connectors is to use white heat shrink for labelling the wires. It's much cheaper than the labelling systems you buy. You can write anything you like on a wire, quite long sentences, whatever you want. And shrink it in place. It's still perfectly readable, but it now won't slip along the wire, and it's smaller than I could have written it by hand. Well, the other thing with heat shrink is you can make it useful for making permanent connections between wires. I very often cut a wire too short, particularly wires going back to a control board, and sometimes have to reroute them. And the proper way of doing that is to replace the wire, but this is a way of joining them that I often use. So this is a soldered connection. So first I'm going to tin the ends of the wire. To get them properly soldered, it's best to heat them from both sides. So now you put them parallel to each other, and with a bit of fresh solder on the gun they'll flow into each other. So that's a pretty well soldered joint now, but to protect it, this is where the heat shrink comes in. You just slide a bit of the heat shrink over the joint and then heat it up. Now this is another tip. If you're on site and you don't have a heat gun with you, you can actually use the soldering iron. Soldering irons get very hot, and if you just sort of hold the soldering iron close to the tube, I think you can see, or almost see it shrinking around it. If you are going to join a wire like this, it's best to find a place where the wire's not going to get flexed fairly obviously. And there's your insulated joint. So I use this trick all the time. You can actually buy a product that does exactly the same thing. This is a bit of heat shrink with a sleeve of solder in the middle. So for this, you just push your wires. You just push your wires in, one from one side, one from the other, and heat the whole assembly up. And this will have to get even hotter because we've got to melt the solder. There, I think you can see that the solder has flowed all around everything. But actually I tend to just use my own DIY technique. It's more flexible somehow. The next sort of connector I'm going to look at, what I call punch down connectors. I think these ones, little things, I think they're actually called IDC. That's what they look like. You can see the row of little bits of metal inside. This is one I've sort of half taken to bits, so if I just pull out one of these bits of metal, that's the shape. And what you're seeing when you looked into the complete connector was these pointy bits at the bottom. So it's a series of these little forked things. So back to the connector. So if I now feed a bit of ribbon cable into it, you can see on this side the little depressions in the connector. It's very specifically made for this this cable. And now all these little fork shaped bits of metal, they're going to puncture the insulation and then force themselves down, and the long thin bit in the hole is going to make contact with metal in the middle. So you're supposed to do this with a proper pair of pliers, which I don't have, so I tend to use my pipe wrench. So we'll just have to hope for the best. Oops. So that now is fully clamped. And then there's an extra bit that pushes on the top. That actually locks it in place. So every one of these forked bits of metal is now pushed through the wire and making contact. 16 contacts in one clamp. It's amazing. This connector is actually a sort of socket which would go into pins on a circuit board. So and they're usually these special units for doing that. This will make the whole thing pluggable. That goes in there. That's it. And then they lock on. And then these are the pins that will be soldered to the circuit board. And of course, equally though, you could use another IDC connector to connect it to another bit of ribbon cable. Well, you might think, why don't I use them all the time? Well, there are two main drawbacks. One is that they're not highly rated. They can only carry 1 amp each core, which is sometimes enough, but it's not always enough, so it gets a bit confusing. The other thing is that running ribbon cable around a machine is different from running round cable, round multi-core around a machine, and is not so convenient really, so I haven't adopted them widely. Another sort of punch down connector, this one widely used by telephone engineers joining wires that are outside. It's a waterproof connector called a gel connector. The two wires go in the two holes at the end, and you can sort of just see the gel, and that's what makes the connection waterproof. If I put one wire in here from this side, and it takes both single strand wire and multi-strand wire. Push another one in there, and then just like with the other ones, we punch it down. Yeah, I think that's the two wires firmly connected and waterproof. I used to use these on the water clock for some of the switches and sensors. They weren't bad, but eventually I redid them so there weren't any connections that were outside. All the connections were inside boxes, but it is particularly severe out on the sea. The last sort of connector I'm going to look at are crimp connectors. And the simplest of these, the spade plug and receptacle. I have to say I don't like them. After chocolate strip, they're my second least favourite. So the receptacle has this shaped bit of metal inside that springs against the actual spade as it goes in. So to do them up, you use a pair of crimping pliers which squash the wire into the connector. Put the crimp over it and squash it down. What could be simpler than that? I'll do the same for the receptacle. And then you just push them together. Well, that's where the problems start. I don't know if it's because they're cheaply made or different manufacturers, but sometimes it's a loose fit and sometimes it's a really tight fit. And this one is a really, really tight fit. I've just about got it in now. There's still a bit of bare metal, so it's not completely insulated the joint. But you push these ones, you push in so hard very often when you come to pull them apart, what happens is this. The wire comes out of the connector rather than splitting the joint. And it always happens at the most inconvenient moment. So they're not really my favourite. A much smaller crimp, and a much better one, are ones that are used very frequently for electronics, for connecting to circuit boards. So the wires go into, these are the sockets, and they go into the pins that usually are soldered to the circuit board on this end, and the pins go in these holes here. To fix the wires to the socket, you have these tiny crimps. So the wire goes in this end, and just as with the spade terminals, there's a special pair of crimping pliers. So we feed the wire into the crimp, squash it up, and there it is, very firmly fixed. These ones, they work very well. And now there are two things to note on these little crimps. They're so tiny, I don't know how well you'll be able to see it. On the back there's a tiny little hooky thing there. That's what keeps them in place in the plastic housing. The other part to look at is the little is this little shape on the end. The point of that is once it's inside the housing, this is what springs against the pin of the plug. So all you do is to now push this into the connector, and it locates with the hook, so it won't fall out again. Well, these do work very well, but they're not ideal for connecting one wire to another wire. And they are limited, I think, to an amp. So they still weren't the holy grail, the perfect connector. A few years ago, still generally rather frustrated by connectors, I did some research and I decided to try a system called Molex Microfit. It doesn't look very different from the ones I was just showing you before, but it can connect one wire to another wire, so it's as well as a wire to a circuit board. You can get sort of plastic shells for all sorts of different numbers of contacts, but what really made it stand out is it can take a current of up to 5 amps. Extraordinary for something this small, and I was amazed that you can fit this really chunky 5 amp cable into it. To think that a tiny thing like that could take as much current as the jack plug that I started this video off with. So this is the receptacle in there, and you can just see the pins in there. So very similar to the previous ones I'm looking at, but with these more exotic ones you have to buy special pliers, and they're very expensive. This is the most expensive pair of pliers I've ever bought in my life. About £200, but it is a very precision thing. I can sort of see the whole thing is worth it. The pins themselves are amazing. I don't know how they could be made. That one's the plug, the lower one, and this one, though it looks identical, is actually a tiny socket. Sort of just see the tube in the end. Actually, using the tool is very similar to the ones I looked at earlier. You pop the crimp in there. And a beautifully crimped wire. I've never ever had one of these pull out. You might think that I've finally found the holy grail, the perfect connector, but life's still not quite so simple as that. So you'll find these little Molex Microfit connectors in all the recent machines. The trouble is, if you have a fault, you really need to isolate individual wires rather than just a pair of wires. And it's quite hard with this because they're kind of all concealed. So what I do is I have some little wires with the crimps on, and I can push them into the individual wires, and then you've got a wire that you can connect to a meter to see what's going on. But it's fiddly, and I don't always have these little leads with me, so it's not a perfect solution. So only a couple of weeks ago I had a situation where there just wasn't space for one of those Molex connectors, and I found myself just joining the two wires by twizzling them up and then popping a bit of heat shrink over the top. And it's not a bad connection, and of course it's easy to undo because you can just take the heat shrink off. But the ironic thing is, it's so uncannily similar to the connections I used to make when I was a kid, when I just twizzled wires together and wrapped them rather clumsily with insulating tape. So sometimes I feel I've almost gone full circle. I don't know, but connectors are exasperating. Anyway, I hope you found something useful in this video. Bye.